So abstract classes are essentially classes that are less than a class. You can't instantiate them. You can't really do anything with them by themselves other than use them as a framework to create a child class. So they're often thought of as a to-do list. So why might you want a to-do list type of thing? Well, most development today takes place in a team. It's not something that you do on your own. So the lead programmer might say, hey, I'm going to give some structure to this and force everyone to have certain methods in all of their classes. Let's say you're building a character for your games, and you say every character has to have the ability to check their health stats. How that happens is up to the designer of the individual character. But every character has to have that ability. So what the lead coder might do is create an abstract class, let's say called character, and build a method inside character that is essentially just the first line. It has no code in it. It just declares the name of the method and says what it's going to return and says what parameters it's going to have. And that's it. That's all that they're going to write. You cannot instantiate that object because there's no code in that method. In order to create an object, you have to extend that class and create a new class. So an abstract class can modify a parent class. So you can have an abstract class as a child class. The abstraction would just continue. It cannot be instantiated. You cannot create an object for this. And some of the methods in the parent class are abstract, but not all of them are. So maybe as the lead designer, I wrote some methods that I thought everyone should have, and I wanted them exactly the same, so I wrote the code for it. But other methods, I just need to make sure you have a method in your class that has that name and has those parameters and returns the value that I'm expecting. So abstract methods only have the header. They don't have any code. So the parent class defines the behavior by listing all of the abstract methods. The child class implements the abstract methods. So the child class has to write the code for that. If it doesn't, then it's also an abstract class. And you'd have to have another child that would eventually implement the method. You cannot create an object from an abstract class unless all of the methods have been implemented. This is a vocabulary word, implement. It's essentially a to-do list. You have things that are listed for you to work on, and it's handed to you. So you have an abstract class that you have to implement. The AP exam likes this, because then they can give you all the headers and everything and tell you to implement this abstract class. Now they have another thing that is even less structured, called an interface, which we'll talk about interfaces too, but it's even less structured than an abstract class. It has nothing in it other than some definitions. Abstract classes can have data. There could be data defined in there. If I decided I want to define every character has a, I don't know, what do we typically talk about game characters, like race and height, right? This is an elf, right? That's how that works. Okay. So here's an example of an abstract class. It's called quadrilateral. You should recognize it because it's the quadrilateral class we wrote before, but this time I made it an abstract class. And it has 4 pieces of data, side 1, 2, 3, 4. It has a constructor that's already defined, so I can use that constructor in any child class just like we could do before. But now it has this new thing called an abstract method, public abstract int get areas. And then that's it, a semicolon, done. Because I have this abstract method and I have declared this class as abstract, I cannot create a quadrilateral object. I cannot use the new command in a runner to create a quadrilateral object. It's abstract. It's not finished. It's a to-do list. And then finally we also have our getPerimeter method. So that would be fine. We could use that once we created the child method. So when you create a child class from this that extends quadrilateral, let's say rectangle, you must implement this method. You have to write code for it. Otherwise Java will throw an error. Any class that extends quadrilateral has to write code for the getArea method. Here is the rectangle class, which extends quadrilateral, just like we did before. It has its own constructor. It's calling to the super constructor, just like we did before, where we're sending AB as our 2 sides used twice. We're rewriting the perimeter method, so it's overriding the perimeter method, and that's fine. It's a different perimeter method. We're using the getSide method, getSide 1 and getSide 2 that we had built before. And then we implemented the getAreas method. We wrote it. If you don't write the getAreas method, then it's not going to work. So let's talk about this for a second. When you have a perimeter, you're adding up all the sides. So it makes sense that you would have to override that. But if it's a quadrilateral, all quadrilaterals, you can get the perimeter just by adding up the 4 sides. No matter what it is, that's going to work. But the getAreas method is going to be unique for each type of quadrilateral. So it would not make sense for the designer of quadrilateral to write a general getAreas method, because it wouldn't work. You can't write the same area formula for a trapezoid that you would write for a rectangle. There's no common area formula. But there is a common perimeter formula. Add up all the sides. We can override it and write something that we think is simpler, but it's fine if every child decided to use the getPerimeter method. It would work. So, if we try to create a new quadrilateral by having a type quadrilateral, assigning it a variable q, using our new constructor, call our new command to call the constructor, put in some numbers, we get an error. This is the error we get. Cannot instantiate the type quadrilateral. Java is fairly clear. It doesn't say because it's an abstract class. It just says I can't do that. The reason is because it's an abstract class. So the error is going to show up. Java is going to definitely let you know you can't do this. So if we create an object with a rectangle, that works. That's just fine. So we have an object, rectangle, R, new rectangle, 4, 5. This is technically calling the constructor of the quadrilateral, because we know rectangle's constructor uses the super reference. Then we can print out the perimeter. The perimeter method we know is overriding the quadrilateral method, because it created their own version of it. And then finally, rectangle 2, we're getting the area of rectangle 2 using our getArea method, which we implemented in rectangle and does not exist other than a header line in quadrilateral. So what if the child class does not finish all of the abstract methods from the parent class? Then this class is abstract as well. It's like it inherits the abstraction. So of course, when does the abstraction end? When all the abstract methods are written. Everything in the to-do list has been checked off. That's the end of it. So abstract methods, again, they're an organizational structure. They're, whether it's organization for you as a programmer in order to organize your thoughts, just like you would do an outline for a research paper, or it's an organizational structure for a team of coders, and the lead coder is creating a class that everyone is going to extend as they build some type of character or something like that. So there is a Blackboard assignment for this. So the assignment is, given this abstract class called fruit, it has a piece of data called mynum. It has a constructor. And then it has two abstract methods. One is toString. Actually, you know what? Let me fix that. I don't think I can make toString abstract. So we'll just leave it as one, eat. Okay? I think Java might have a problem with that. So we'll leave it just as the one method. Because technically toString's already implemented. So we have a public abstract method called eat, and it takes some number. You can implement that any way you want, but you are to create a child class or a subclass called banana. You can kind of figure out where this is going, right? Number of bananas, eat one, maybe we should decrease it by one, right? Make it nice and simple, straightforward, okay? Goal is here is just to see that you're going to create a class, you're going to extend the other one, and you're going to implement the method that's there. You might see an AP question like this, probably not dealing with fruit, but you might see an AP question where they give you some abstract class and they ask you to build a child class based upon that abstract class. That could be one of the free response questions, or more than likely part of a free response question. So that's it for the lesson today. Never stop coding.